Hi there, this is video 27 on compound interest, and we're solving for n. And I'm going to do this first question two ways. Well, actually three ways, right? First one, we talked about estimating. So I'm just going to put up here. And you don't have to do this. I usually estimate if like my final answer looks kind of weird, then I will check it. All right, so you want $20 to double when invested at 8% compound annually. So my estimate is the rule of 72. And if that looks familiar, it's because these are just the rule of 72 questions from, let me check, from video 25. And we're just going to do it mathematically, and let's just see how close they are and what happens when it's semi-annually and quarterly and things like that, how close our actual estimates are. A-P-I-N. And as always, I just love the fact that the formulas I've found, and it's taken me a while to get them to the point where they're useful, all use the same variables. I've seen the departmental exams and they give you a formula sheet and it's just horrendous because there's all these formulas and they're not connected, and it just seems like such a waste of time. But don't worry, you don't have to write my department. You don't have to write a departmental. All right, so we got N is our time period, and we don't know. That's the point of this question. Our interest is 8%, and we're doing it just like we did before. 8 divided by 100. I'm going to do divide by 1 because it says annually. Oops, not bad. 8%, $20, double, and annually. So that's going to be 0.08. And I'm going to start with $20, and I'm going to double it to $40. So A is equal to P1 plus I to N. A is equal to 40. 1 plus, oops, interest, I know interest. 0.08 to N. Oops. Oh, are you yelling at me? You should be yelling at me. Got that in the wrong spot. I know A. Should pay attention. A is 40. P is 20. Okay, so what can we do? I'm going to show you how it worked with the original formula so you can kind of do it, but then I'll show you using the N formula, the logarithmic one. All right, well, I can put those together. So 40 is equal to 20, 1.08 to the N. And if you remember from before, it's a little bit like when we had the interest question. We got to get rid of this because we can move that over. So we can divide this side by 20, divide this side by 20. So 2 is equal to 1.08 to the N. And this is where a lot of students will get stuck, right? Without the log formula, you're kind of stuck with guess and check. And I'm just going to cheat. Now throw this here. What do I mean by guess and check? Well, I need to end up with 2, and I'm going to go 1.08, and I'm just going to randomly pick 5. Random. So now I'm going to try that on my calculator. 1.08 to the 5th power. Well, that gave me 1.469. That's not big enough. I'm trying to get 2. So I'm going to try 1.08. Let's try to the 10. 1.08 exponent 10. And I'm just, again, randomly picking this. I know 5 is not big enough. I don't want to waste my time by going 6, 7, 8, 9, 10. Maybe it's 40. I don't know. So I'm going to use a bigger number. Check it. All right. So that one gives me 2.15. So this is too small. This is too big. Pick a number in between. Now I'm going to cheat a little bit. because my estimate over here says it should be about 9 years. So 1.08 to the power of 9. Oh, that gives me 1.999. That's darn close to 2. So you can do it, but it really ends up being guess and check. But if you are, you can't come up with anything, your brain is not working, you kind of forget how to do this, that's what you do. It's guess and check. I will remember to put this with the answer key. Using the logarithms, I'm going to put my sheet back here. Where can I put it so we can all see it? Not enough room. So this is from video 26. N is equal to the log of A over P divided by the log of 1 plus I. So N is equal to the log. A was 40. Whoopsie, don't forget the word log. Over 20 divided by the log of 1 plus 0.08. I'm really sorry I didn't leave more room for these questions. So N is equal to the log of 2 over the log of 1.08. Please. Log 2 divided by log 1. No, not 10. Log 2 divided by log 1.08. All right, so N is equal to 9 years. And why would I do all that work if my estimate was going to be 9 years and the estimate was completely right? Exactly. But the estimate only works or is most accurate when you're talking about annually. Okay? Let's see how much a difference there is if we're doing something when it's compounded semi-annually. And I'm not going to do the guess and check, but I am going to write that here. I'm just going to go straight to my log formula. All right. We're going to take an investment. It's going to double 1.2% compounded semi-annually. What do we got? So we got A, P, I, N. All right, so I got 1.2% divided by 100 divided by 2. Zero 0.006. I'm going to show you another trick here. I'm going to pretend if I had my number of years, I would multiply it by 2, and then I would get some number over here. And I'll show you right away how this is going to become important. Now, there's a little bit of a problem. I don't have any A. I don't have A. I don't have P. All I know is it's going to double. Suggestions? I feel like I'm Dora the Explorer. You guys should be yelling at the screen. Make up a number. Let's going to say we're going to take 100. And when that doubles, that becomes 200. And it really doesn't matter what number you pick as long as you double it. So that means this is 100 and this is 200. So I'm going to use, again, I'm going to use this one, save this some time. N is equal to the log of A over P divided by the log of 1 plus I. Always writing out the formula. It's like practicing spelling words. N is equal to the log of A, which was 200, over P, which was 100, divided by the log of 1 plus 0.06. That's going to give you the log of 2. See, that's what I mean. It doesn't matter what number you pick there, 200 and 100. If I chose 200 and 400, you know what? That would have 400 on top, 200 on the bottom. It would still go to 2. And equals over log 1.06. Divided by log 1.006. Oops, look at that. I lost a 0 in there. That would make a big difference. 10 in there equals. Okay, so 1, 1. Here's one of the other tricks when you're solving for this. Whatever answer you get here, that's in time periods. So this one, I didn't have to say anything. It was in years. But this is 115.87 semi, I don't know how to write this other than semi-annual time periods. And what that means and why I did this is that means this answer is here. And normally we start here and we multiply by 2 and we get there. So if we're here and we want to go back, we're going to have to divide that by 2 because there are, well, maybe that's even easier to see. If these are happen twice a year, if I want to know how many years, we're going to divide by 2. So 57.9 years. Why not just say 58 years? Now remember when we did the estimate? We went 72 divided by 1.2, 72 divided by 1.2, 60 years. So when it was annually, we were spot on. It was exactly the same. Semi-annually, it's a little bit less. And that makes sense, right? The more often you compound, the faster you're going to make money. So it's going to make a little bit of a difference. All right, now let's see if we can move that enough. There we go. So A, P, I, N. So now we have 5%, and we're going to compound quarterly, and we're looking at doubling again. So 5% divided by 100 divided by 4. And it's doubling again, so you know what? I'm going to do the 100 going to 200. 100 there, 200 there. I'm just thinking, if this part confuses you guys, don't worry about it. Just remember there's that extra step that you have to watch because you're getting in time period. So A over P. Oops. A is 200 over 100. Oopsies, I forgot to do that. 5 divided by 100 divided by 4. 0.0125. 1 plus 0.0125. So we have n is equal to log 2. Oops, I don't need the brackets anymore. 1.0125 log 2 divided by log 1.0125, 55.79. All right, now let's look at our estimate. 72 divided by 5. 72 divided by 5. All right, 14.4 years. Okay. Oh. What the heck? That's where, you know what, doing the estimate either before or after the question is going to save you, because this is 55.79 quarters. Whatever this is, that's what you get out the back end, right? It's going to be the same thing. So there are 4 quarters in a year. So if we then divide by 4, oopsies, let's go. 55.79 divided by 4, and n is going to be 13.9. I'm just going to say 14 years. Much better, right? So whether you do the estimate kind of at the start to get a ballpark of where your answer is going to be, or you do it at the end, it's really worth your time, because really that's the most common mistake students make, is they'll forget to do that little adjustment. It just feels weird because you're adjusting at the end, and we're so used to adjusting at the very beginning. Now let's take a look what happens with these ones. These are the ones that we were estimating. Oh, this one shouldn't be too bad, but let's try it. Better yet, pause the video. All right, how long? Don't know. We got 3.6 divided by 100, divided by 1 because it's annually, so 0.036. And we are starting with $700, and we are growing it to $2,800. So that was nice to actually have the money in there. Sorry. Boop. Compounded annually. Should have done that first, I forgot. There's our formula. Now we're going to plug it in. Plug it in the bottom. So n is equal to, okay, so this time at least we're getting something besides log 2. Right, we kept getting log 2 because we kept talking about how long will it take to double. So log of 4 over log of 1.036 . All right, so n, oopsies, I don't need to write n again, is 39 years. Sorry. I'm just checking our sheet. When we guessed on here, it was question E, and we had 4 years, so we got 39 years. So that's still pretty cool. All right. How long will it take $400 to go to 1,000 compounded monthly at 4.5%? Now, we estimated somewhere between 16 and 32 years. That's a pretty broad range, right? Yeah, you'll have this money. It'll grow somewhere, right? That's terrible. You don't want to do math or finance like that. That's where the rule of 72 kind of falls apart. Not to mention, we're also looking at monthly. And we're using our handy dandy little logarithm is going to work amazing. So A, P, I, N. Okay, we did it. My bad. I, 4.5 divided by 100 divided by 12 0.00375. The amount at end is $1,000. The amount to start is 400. Whoopsies, 400, not 4,000. And let's get our formula going. I was just embarrassed thinking how long you guys stare at the top of my head with this, but I'm terrible if I try and look at the screen and do my writing. And the truth is, even if I wasn't doing this as an answer key for you guys, if this was a test or something and you didn't ever get to see my answer key, I'd still be writing my formula out every single time. It just helps me, and it convinces, I make sure that I get my numbers in the right spot by doing that. So it's 1,000 over 400 over the log of 1 plus 0.00375. Just going to double check. There's 2 zeros there, 2 zeros there, and I remember to put 2 zeros there. Okay, 1,000 divided by 400. Well, 2.5. Whoopsies. 2.5 divided by log 1.00375 log 2.5 divided by log 1.00375. Okay, 244.8. Again, our answer is really wonky, but what units is this? This is months. Right? Because whatever this is, it's going to be the same thing. So we're going to divide by 12 to convert it into years. You get 20.4 years. Okay, well, that's certainly what we said. It's somewhere between 16 and 32. All right, that was a long one. That's probably the scariest formula that we have to use. And it's not scary, it's just odd looking because for the most part, people aren't used to using logarithms. Take chemistry, it'll become your best friend. All right, we're done.